So we're all familiar with the lottery, and we know that you win the lottery by when you're given a certain number of cards. So given n cards or a stack of n cards, we pick r cards. And if we pick the correct r cards, there's one correct set of r cards. And if we pick that correct set, we win the lottery. So let's say, for example, let's say there's 55 cards. So let's say given So let's say we're given 55 cards, and we're asked to pick 5 cards. We're asked to pick 5 cards, and let's say one of these sets of 5 will end up in us winning the lottery. Well, the first question is how many such sets of combinations of, or how many such sets of 5 are there out of a set of 55? Well, this is going to be given by 55 choose 5, which is 55 factorial over 55 minus 5 factorial over 5 factorial. And let's work this out on the calculator here. So as our TI-83 Plus app here shows us that 55 choose 5 is 3,478,761, and if we just calculate it as 55 factorial over 50 factorial times 5 factorial, we get the same answer. So 3,478,761. But that's 55 choose 5. What about 55 choose 1? So this would be the scenario that we have 55 cards. We're asked to pick 1 card from the stack. How many different ways can we do that? Or how many different sets of 1 cards, or really how many different cards can we pick? This would be equivalent to 55 factorial or 55 minus 1 factorial divided by 1 factorial. This is just 55 factorial over 54 factorial times 1 factorial, and hopefully you can see that 55 factorial over 54 factorial is just 55, and divided by 1 factorial. 1 factorial is just 1, that's 55. This should make sense because, well, if you're picking sets of 1 card, you're just picking 1 card, and there are really 55 ways to do that because there are 55 cards in the stack, right? Now, what about 55 C2? So if you're asked to pick 2 cards from the stack, how many different sets of 2 cards can you pick? Well, that's going to be 55 factorial over 55 minus 2 factorial or 2 factorial. It's just going to be 55 factorial over 53 factorial divided by 2 factorial. And this is just 55 times 54 divided by 2 factorial. Right? Or this is just going to be 55 times 27. So by picking 2 cards instead of 1 card, you've upped your number of choices by a factor. You've upped the number of ways you can pick those sets of cards by a factor of 27. Now, the first question I'm going to ask is, well, how many cards should be in a set for this number of choices to be maximized? Or another way of asking that, so you're given 55 cards. how many cards should you be asked to pick out of that so that you will have the maximum possible number of ways of picking them? To really understand the answer to that question, I want you to understand the structure of this NCR here. So 55, choose R, where R is the number of cards you're picking. Well, that's going to be 55 factorial over 55 minus R factorial over R factorial. And you can see, regardless of this, the value of R here, R being the number of cards you're picking out of the set of 55, the numerator is 55 factorial. So we're really trying to maximize this denominator, and we have to ask ourselves what value of R will contribute to us maximizing this denominator here. Well, let's see. If R were 1, or really we want to minimize this denominator, right? We want to maximize this quotient here. So numerator is fixed. We want this denominator to be as small as possible. Well, how are we going to do that? Well, let's do some numerical exploratory work here, and hopefully that'll reveal the answer. So when you look at the case when R equals 1, let me write that a little bit more neatly here. So when R equals 1, the denominator is going to be 55 minus 1 factorial times 1 factorial. What about when R equals 2? The denominator is going to be 55 minus 2 factorial times 2 factorial. Well, what are these numbers here? This is going to be 54 factorial. So drag this way. It's going to be 54 factorial times 1 factorial. And this is 53 factorial times 1 factorial. So this here is going to be 51. So this is basically the same thing as 54 times 53 times 52 all the way to times 2 times 1, and all of this times 1 factorial, which is just 1. What about this case? Well, this is 53 times 52 times 51, again all the way times 2 times 1, and then this should be 2 factorial here, okay, times 2 factorial. Well, what's 2 factorial? That's just going to be 2 times 1. Now if you look here, these both share 53 factorial in common. The difference is that this 55 minus 2 factorial times 2 factorial multiplies this 53 factorial by 2, whereas this 55 minus 1 factorial times 1 factorial multiplies it by 54. So from these two examples, it looks like when we increase R, it looks like we're gonna be making this denominator here 55 minus R factorial over R factorial smaller. But how far does that hold? Now let's compare the case when R equals 10 with the case when R equals 20. So when r equals 10, we have a denominator of 55 minus 10 factorial times 10 factorial. This is 45 factorial times 10 factorial. So 45 times 44, and so on, times 2 times 1 times 10 times 9, and so on, times 2 times 1. Okay, when r equals 20, the denominator is 55 minus 20 factorial times 20 factorial. That's 35 factorial times 20 factorial. That's really 35 times 34, and so on, times 2 times 1 times 20 times 19, and so on, times 2 times 1. So let's compare these two quantities. They both have 35 factorial in common. If you can see this first one here, 45 times 44, this will be 43, 42, and all the way to 1. This contains 35 factorial. And clearly so does this one. But what about the rest? They contain 20 other factors here. Both of these contain 20 other factors. This top one contains 10 factorial, so 10 times 9 times 8 times 2, and so on, times 2 times 1. And then integral factors between 45 and 36. So 45 times 44 times 43, and so on until 36. Well, what about this one? This contains 20 factorial, which consists of, well, 10 factorial and 20 times 19 and so on times 11 times 10. Those are the two components. So we have 10 factorial here, 10 factorial here, 35 factorial in both situations. The point of difference is really the other 10 numbers are 11 through 20 here, whereas they're 36 through 45 in this case. So again, this is going to be bigger, and this is going to be smaller. So again, it looks like if we increase the value of r, we are still decreasing the size of the denominator, and thus we're going to be increasing the size of this 55 choose r. But is there a point where that no longer happens? So in all the 4 cases we've looked at so far, we have 55 numbers, and that's the case for really all denominators of the form. All denominators of 55 choose r, and the denominators are 55 minus r factorial times r factorial. So all of those possibilities consist of 55 factors each. All right, the first case was 54 factorial times 1 factorial, so that's 54 up to 1 times 1. And then the second case, 53 factorial times 2 factorial, so 53 times 52 down to 1, and times 2 times 1. And then in the case of 45 factorial times 10 factorial, 45 times 44 down to 1, then times 10 times 9 down to 1, and in the case of 35 factorial times 20 factorial, 35 down to 1, and times 20 down to 1. Well, if you look at each of these cases, right, they each contained a 35 factorial, like this one. Inside of 54 down to 1, you have 35 down to 1. Inside of 53 down to 1, you have 35 down to 1. So then we have to ask ourselves, well, what's the difference in the other 20 elements? Well, in this case, it's 20 to 1. 20 times 19, and so on and so forth, times 2 times 1. In this case, it's 10 to 1, but also 36 to 45. In this case, it's 36 to 53 and 2 to 1. It should make sense, hopefully, that this 36 to 45 is going, and 10 to 1 is going to be bigger than 20 to 1. Why? Because they both have this 10 to 1 in common. whereas this one, the rest is 11 through 20, while this is 36 to 45. So, and 36, or let me do it the other way, 45 to 36, those numbers multiplied together are going to be bigger than 20 down to 11. And really, we can make a similar argument here if we want to compare this this last one here with the first one. And this is also going to contain a 35 factorial, but what about the rest? The rest here is 36 through 54 and 1, while the rest here is just 20 to 1. So you can see that this is clearly bigger. But there is a point when making r bigger does not make this denominator smaller. So let's say r is 27. This would mean that we are drawing 27 cards out of 55. So we would have 55 choose 27. This would be 55 factorial divided by, well, divided by 55 minus 27 factorial. That's 28 factorial times 27 factorial, right? So the denominator here would be 28 factorial times 27 factorial. That's 28 multiplied by 27 all the way down to 1. Then times 27 multiplied by 26 all the way down to 1. What about if r equals 28? Well, again, we'll be having 55 minus 28 factorial. Well, that's just 27 factorial, right? That's the 55 minus r part. And the r part is just going to be 28 factorial. But these two products are really the same thing, right? This is 28 factorial times 27 factorial. This is 27 factorial times 28 factorial. These are the same thing. So it looks like at this point, when we hit r equals 28, we're kind of repeating ourselves. What about when r equals 1? So let's say r equals 1. Well, if r equals 1, then we have what? 50. We're going to have 55 minus 1 factorial. Or have we considered that case already? No, let's say r equals 54. So say r equals 54. Okay, so if r equals 54, I'm going to write it below here. 55 minus 54 factorial, well, that's just 1 factorial, right? So 1 times, or I'll just write 1 here. Well, that's our 55 minus 54 factorial, but then we have the 54 factorial part. So that's going to be 54 times 53, and so on, times 2 times 1. But this is the exact same thing as if r equals 1, right? Here we have 54 factorial times 1 factorial. That's the same thing as 1 factorial times 54 factorial. So really, in this case, in general, we could say 55 and we can express this more generally by saying, well, when r2 equals 55 minus r1, 55 minus R2 factorial times R2 factorial equals 55 minus R1 factorial times R1 factorial. So in other words, if we are looking at this, the denominator of this expression here, if we interchange, if we substitute R with 55 minus R, we're still going to get the same answer. So really this trend will continue, this trend of decreasing denominators with increasing values of R will basically continue until R equals 27, and then the denominator will increase. Well, it'll be, then you'll have a repeat of R equals 27 at R equals 28, and then at R equals 29 you'll have a repeat of R equals 26. So really this denominator is going to be minimized when R equals 27 or 28. In other words, and the maximum number of combinations is going to result when R equals 27 or 28. So just right here, it's 27 or 28 maximizes number of possible card sets. So another way of saying that, if you're asked to pick 27 or 28 possible, or 27 or 28 cards from a set of 55 cards, or let me say it this way, if you're asked to pick R cards from a set of 55 cards, the value of R that will result in the maximum number of sets of cards is going to be 27 or 28. Well, if only one of those sets wins, it should make sense that the lowest probability of winning is given with R equals when you're picking 27 or 28 cards. But what about the highest probability of winning? Well, the highest probability of winning is going to be when this denominator is as high as possible, right? And hopefully we saw, if you remember, we saw that this denominator gradually gets smaller as the value of R gets bigger, and that trend continues until R equals 27. And after R equals 28 onwards, you'll have a repeat in the reverse order. So really the values, if you're asked to pick, let's say R equals 1 or 54, will minimize number of possible card sets. And thus this will maximize your likelihood of winning. So if you're asked to pick a set of 54 cards, if you're asked to pick a set of 1 card or 54 cards, this will minimize it. Of course, if you're asked to pick 55 cards, there's really only one way to do that. So this will give you, there are 54 ways to pick 1 or 54 cards out of a set of 55. And there are a whole lot more than 54 ways to pick 27 or 28 cards. And if you want to know the exact number of ways, well, this is going to be given by 55 factorial over 27 factorial times 28 factorial. And this is basically (54) times 53 and so on until 28 divided by 28 and so on until 1.